If you think stepping on Legos is bad, try stepping on one of these. Not only they're far more likely to be found in workshops, they're also more likely to draw blood. You'll be cursing and swearing even more when you found out that this video will talk about op-amps once again. Let's get started. To calm you down, we'll be using an operational amplifier as a comparator. The whole difference between the two is that comparator lacks a stabilization circuit for strong feedbacks and is optimized for speed. Such details don't matter for you today, therefore we'll be using the same chips as we did in the previous videos, an OP37. Okay, let's brush up the basics. Comparators amplify the difference between the input pins by a huge factor and clamp it between saturation voltages. In practice, this means that comparator will go to positive saturation voltage when non-inverting input is higher than the inverting one. If non-inverting input has lower voltage than the inverting one, output will be at negative saturation voltage. Want the proof? Well, here it is. Red Pitaya's output 1 goes to non-inverting input and output 2 goes to inverting one. Input 1 observes the comparator's output. The circuit is powered by plus and minus 3.3 volts. Let's now set output 1 to be sine wave and make it visible, and output 2 to be DC level with display enabled. We can see that output is higher whenever sine wave is about DC threshold. If we move the threshold up and down, comparator still behaves the same way. We have now constructed a regular comparator. We can modify it to construct an inverting comparator. You shouldn't be too surprised to learn that all you have to do is swap the input. But does it really work? Yes, it does. And here's the proof. The fact that inverting comparator is just a regular one with swapped inputs should come as no surprise. The real question should be what happens if we applied a load resistor to a comparator's output. Let's find out. Connect a resistor to comparator's output and observe the difference. Don't forget to connect resistor's output terminal to the ground potential. Here is the before and here is the after. Hardly any difference. Okay, that was underwhelming. But what if we connect two resistors in series? Or even better, use a potentiometer. So let's modify the circuit and here is the output. Why is my alter ego so excited about this experiment? Nothing has changed. That's because you have to connect Red Pitaya's second input to a potentiometer's wiper terminal. Okay, I'll humor you, or myself. Let's connect the green probe to the potentiometer's wiper terminal and see what we've got. So the green trace follows the yellow one, and its attenuation is regulated by the potentiometer. What's so special about it? If you connect the wiper terminal to the non-inverting input, the threshold voltage of the comparator should change after each transition. Modify the circuit and we'll talk about it later. Before and after. Output toggles whenever input signal crosses the threshold voltage, but therefore voltage changes every time the output toggles. Okay, what we've just made, it's a Schmitt trigger. The threshold voltages from high to low and low to high are different. It acts as a comparator with hysteresis, and that's ideal for use with noisy signals. Let's assume this is the ideal signal, and this is the noisy counterpart. With threshold level here, comparator signal will have unwanted transition. A Schmitt trigger with appropriately set hysteresis will have only one transition. We've just shown for a non-inverting Schmitt trigger, but we made an inverting one before. The only difference between the two is where the input signal and reference voltage are connected. In our case, output 1 and ground pin were swapped. One more thing before we take a look at the equation. If you wanted to move the threshold voltage from around 0 volts to around some other voltage, replace the ground pin with the desired reference voltage. Here is a quick rundown of the equations. I'll let you look at the schematic and equations while I'll talk. Threshold voltage can be moved by applying a voltage here or here instead of ground potential. High threshold voltage and low threshold voltage are moved along with reference voltage. Okay, that's it for today and all you need to know about Schmitt triggers. Remember, like, share and subscribe, and don't step on chips barefoot.